This is Bob Capetta from the University of Illinois at Chicago, and this lesson is on sectors. A sector is a piece of a circle. The relevant notions will be the radius of that circle, the central angle, the area of this piece, and the arc length of this piece. We typically use the letter S to represent arc length of a sector. To do this analysis, we'll have to remember the circumference of a circle and the area of a circle. Circumference of a circle is 2 pi times the radius. Area of a circle is pi times the radius squared. So our question is, the sector is cut from a circle with a radius of 20 feet and a central angle of 30 degrees. We want to find the arc length of that sector. So that's the distance from this point to this point. That curved distance. That is a fraction of the entire distance around the circle, i.e. it is a fraction of the circumference. So we're going to find out what that fraction is. 30 degrees is what we have for our sector. So what fraction of the entire circle is that? That's 30 degrees out of 360 times the entire circumference. What is the entire circumference? That, of course, is 2 pi r. So 30 degrees divided by 360 degrees is our fraction of the circle. 2 pi times the radius, 2 pi times 20 feet. 30 degrees over 360 degrees is 1/12. 2 pi times 20 is 40 pi feet. So 40 over 12, dividing 40 by 4, I get 10. Divide 12 by 4, I get 3 times pi. And we get that arc length is 10 pi over 3 feet. If you have access to a calculator, that is an arc length of about 10.47 feet. Our next question says 2 cities lie on the same line of longitude. So in other words, one is directly north of the other. One city is at 10 degrees north and the other is at 55 degrees north. Assuming the Earth has a radius of 3960 miles, let me fix that. And that's fixed. So assuming the Earth has a radius of 3960 miles, find the distance between the cities. So here's how we have to visualize that. 10 degrees north of the equator, 55 degrees north of the equator. So the angle between those two cities from the center of the Earth is just 45 degrees. The distance between the two cities along that line of longitude will be the arc length of this sector. So we have 45 degrees between the two cities with the radius of 3960. From there we can go ahead and find the distance between those two cities. So there's your radius and your central angle of 45 degrees. The arc length is the fraction of the circle times the circumference of the entire circle. Our fraction is 45 degrees out of 360 times the circumference of the entire circle, 2 pi times the radius, 2 pi times 3960. 45 over 360, I believe that's 1/8 times 2 pi times 3960. 2 pi over 8 reduces to pi over 4. Pi over 4 times 3960, which actually reduces to 990 pi miles. And if you have a calculator, you can approximate that to about 3,110 miles. Our next example is a pendulum. It has a length of 12 feet, so this is 12 feet, a central angle of 60 degrees. How far does it travel from one blue point here to the other blue point? So we're going to label our radius and our central angle, 60 degrees, and our radius is 12. And yes, this is indeed part of a circle. So that distance will be a fraction of the circumference, 60 degrees divided by 360 degrees, times the circumference, times 2 pi times the radius. Our radius is 12 feet for this pendulum. Our central angle is 60 degrees. Fraction times the circumference. Fraction 60 out of 360. Circumference 2 pi r, 2 pi times 12 feet. 60 divided by 360 is 1/6. And 2 pi times 12 is, of course, 24 pi. So we get 1/6 times 24 pi, or simply 4 pi feet. And if you have a calculator, you can approximate that to 12.57 feet. Now, we do have a shortcut we can use in certain circumstances. The arc length S is the fraction, so central angle divided by the entire circle, times the circumference. So in degrees, it's not much of a shortcut. You take theta degrees divided by 360 degrees times 2 pi r. We don't really have a shortcut if our angle is given in degrees. But in radians we do, because your fraction in radians is theta radians out of 2 pi total. and your circumference is 2 pi r. You'll notice the 2 pi's cancel, and all you're left with is r times theta. So if you're given the central angle in radians, this is kind of a nice shortcut. All you've got to do is multiply the radius times that angle in radians to get the arc length s. So there is our rule. And looking at this, if we want to find s is just r times theta. R is 3, theta is pi over 3. 3 times pi over 3, which is pi. But that only works if the angle that you're given is in radians. Don't use it if what you're given is in degrees. We don't really have an easy shortcut in that circumstance. Again, to our formula for circumference and area. This time we're going to focus on area. Same sector, cut from a circle with a radius of 20 feet and a central angle of 30 degrees. We want to find the area of that sector. So how many square feet is that? But that's going to be a fraction, again, 30 degrees divided by 360 degrees. This is 1/12 of the entire circle. But what is the area of the whole circle? Pi times the radius squared. So the area of the sector is that fraction times the area of the circle. Our fraction here, 30 degrees over 360 degrees times pi times the radius squared. Pi times 20 feet squared. 30 degrees over 360 is 1/12. Pi times 20 feet squared is 400 square feet. 400 divided by 4 is 100. 12 divided by 4 is 3. So we get 100 pi over 3 square feet as an exact answer. If you have a calculator, you can approximate that to 104.7 square feet. Our next question, we want to find the area of the windshield cleaned by this windshield wiper, and that's that gray area here. We have a big sector and we have a small sector. So the area will be the difference of those two sectors. The big sector has a radius of 10 inches. The small sector, if the arm is 10 but the blade is 7, the difference of those two is 3. The small sector right here has a radius of 3 inches. So again, the area of the sector is the fraction times the area of the circle. The area of the big sector, 95 degrees divided by 360, times pi times the radius squared. That's, of course, 100 square inches. The area of the small one is what that should be. Let me go ahead and fix that. So the area of the small piece is the fraction, 95 degrees out of 360 degrees, times pi r squared, times pi times 3 inches squared. That's the small piece. So when we actually plug this in, we get about 82.9 square inches for the large piece. So that's everything. And the small piece gives us 7.5 square inches. So the area in between would just be the difference, would be 82.9 square inches minus 7.5 square inches would give us this gray area here, which is the part of the windshield that the wiper is actually cleaning, or about 75.4 square inches. Well, there's a shortcut here as well, although it's not quite as efficient as the shortcut for arc length. You'll recall we said s equals r theta was our shortcut for arc length, but that's only true if theta is in radians. Let's develop our argument. And again, with degrees, we don't really have a shortcut that's going to work for us. So we take our fraction, theta degrees divided by 360 degrees times pi r squared. No shortcut. But for radians, a bit of a shortcut. The area of the sector, theta radians divided by 2 pi radians times pi r squared. You'll notice the pi's would cancel, and you'll get theta over 2 times r squared. So indeed, theta over 2 times r squared is what we see. We typically write that as 1/2 times r squared times theta. So if you can remember that, it's a useful shortcut. But frankly, I just prefer to go back to do the fraction times the area of a circle. But let's quickly do one example. We want to find the area of this sector. So how many square inches, square feet, square meters is that little piece? We developed our shortcut for area of a sector, 1/2 times the radius squared times the angle in radians. The radius here is 3, so it'd be 1/2 times 3 squared times the angle in radians times pi over 3. And what's going to happen there? 3 squared divided by 3 is just 3. Upstairs we have a 3 and a pi. Downstairs we have 2. So we get the area of that sector is going to be 3 pi over 2. And that will conclude this lesson.